Hi friends, this is Sujivna, belongs to CSC D section of Adi Shankara Institute of Technology. Today I am here to present my tech talk on the topic of transformers. Today I am going to say what is the need of transformers, introduction of transformers, history of transformers, principle, construction and types of transformers, and at last what are the applications in day-to-day life of transformers. Let's know what is the need of transformers. In most cases, appliances are made in such a way that they should work under some specific voltage. These transformers helps us to maintain such voltages at proper level. The transformers are the main part in the transmission of electricity. Transformers are used to increase the voltage at power generating centers are called step-up transformers, and they are used to decrease the voltage when we are using in household appliances. These transformers are called step-down transformers. By increasing the voltage, the loss of electricity can be reduced in the transmission of electricity. Now let's go into the introduction of transformer. Transformer is a static device. Static in the sense it doesn't rotate, it stays in the place where it was uh, fixed from the starting. It transforms electrical energy from one part of the electronic circuit into the other part of electronic circuit without any change in the frequency. It works on the Michael Faraday's law of electromagnetic induction. Now the history of transformers. The first transformer was developed by Otto Blaski, Miska Derry and Kaloni Jibarnauchi, and this transformer is named as ZPD transformer in 1885. Further in 1885, William Stanley practically changed the design of the first transformer and made it as three-phase induction transformer. The design of William Stanley was firstly commercially used in the USA in 1886. And now let's know under which principle the transformer is working. The transformer is working under the principle of electromagnetic induction. Then what is electromagnetic induction? When the current is passed through primary coil, this primary coil acts as an electromagnet. When this primary coil attains the properties of electromagnet, then some flux is induced in the primary coil. When the secondary coil comes in contact with the primary coil, some EMF is induced in the secondary coil having some magnetic field lines. And by the above lines, we can state a formula that Vs is equal to Ns into d pi by dt, where Vs is secondary winding voltage, Ns is secondary winding turns, and pi refers to the flux produced in the primary coil. Let's have the construction of transformer. The first part under the construction is laminated core. Cores are designed not to have current in it, but still there is a leakages current or the eddy currents present in it. To minimize these currents, the cores are laminated. Next, windings made up of copper or aluminium coated with very thin layer of insulation. The third part under the construction is tank, also known as conservator tank. The main function of conservator tank of transformer is to provide adequate place for expansion of oil inside the transformer. It is usually cylindrical or cubical. Next, fourth one is isolation. It is provided by using synthetic oil between core and tank. And the fifth one and the main part is breather. When the temperature changes occurs in transformer, insulating oil, the oil expands or contracts, and there is an exchange of air also occurs when the transformer is fully loaded. When transformer gets cooled, the oil contracts and goes inside, and the air which is filled in the oil tank will come out. And when the oil is expanded, the air comes out, and when the oil is contracted, the air is absorbed within. Now let's have the types of transformers. Based on three classes, the transformers are divided. The first class is based on construction, based on winding and based on the coolant material. Now the first one based on construction. Under based on construction, the transformers are of three types. Those three transformers are core type transformers, shell type transformers and spiral core transformers. Under based on winding, again the three types of transformers are present. They are step up transformer, step down transformer and isolation transformer. Based on coolant materials, again the transformers are classified into three types: oil filled self cooling transformers, oil filled water cooling transformers and air blast transformers. Now let's have a deep look on these types of transformers. First one, based on construction. Under based on construction, the first type is core type transformers. It has two limbs and the windings are wounded around these two limbs of the core material. Second one, shell type transformers. Its core has three limbs and two windows. Both the windings are wounded on the central limb over one over the other. Spiral core transformers. This core construction is similar to the wheels of spokes. These windings are wounded to these spokes like structures. Based on winding. Under based on winding, the first transformer is step up transformer. The number of windings on primary coil is less than the number of windings on the secondary coil. It is also presented as NP is less than NS. Step down transformers. Number 2. The number of windings on primary side is more than the number of windings on secondary side, also represented as NP greater than NS. And the third one is isolation transformers, where the number of windings on the primary coil is equal to the number of windings on the secondary coil, also represented as NP is equal to NS. Now third type, based on coolant material. Under the coolant material, the first type is oil-filled self-cooling material. Oil-filled self-cooling type uses small and medium-sized distribution transformers. The assembled windings and core of such transformers are mounted in a welded oil-tight steel tanks provided with a steel cover. The oil helps in transferring the heat from the core and the winding to the cast iron where it is radiated out of surroundings. Second type is oil-filled water-cooled transformers. This type is used for much more economic construction of large transformers. The cooling coil is mounted near the surface of the oil through which the water keeps circulating. This water carries the heat from the device. The third one is air blast transformers. This type is used for transformers that uses voltage below 25,000 volts. The transformer is used at houses. The applications of transformers in our day-to-day life. First one, transmitting electrical energy over long distances through wires. Second one, transformers with several secondaries are used in television and radio receivers where several different voltages are required. Third one, used as voltage regulators. Fourth one, used almost everywhere in day-to-day life. Thank you friends.